Today we're going to be working on reflections and symmetry. I've actually cut off the top of this foldable on accident. It has A and then a blank. That's supposed to be reflection up there. And is a mirror image of a given object across a line called the. This is line of symmetry. And then the next one is called rotational symmetry. Is when a shape can be rotated less than 360 degrees and still appear the same. So the first set of these, it says draw the lines of symmetry if any of the following figures and state the angles of rotation if any. So the first thing we're going to do are lines of symmetry. So that's where you could put the line and it would be a perfect reflection. So on this smiley face, we could split it right down the middle, and the left side looks the exact same as the right side. So there is only one actual line of symmetry. And I'm just going to do all the lines and then we'll do the rotational. So this one can go through all the point to points. So 1, 2, 3. Those should all actually all intersect in the middle if I had drawn those lines straight. So besides from point to point, it can also go straight midpoint to midpoint from side to side. So like here to here. That's 4, 5, and 6. So this one actually has 6 of them. Now on a circle, I could put one here, but then I could just go fractionally distant and do one here, and I could do that all the way around. So we actually say a circle has infinitely many lines of symmetry, and this means infinity. It has infinitely as many lines of symmetry. It doesn't matter how many times you turn the circle, it'll always be the same. This one we can go from point to point. So 1 and 2, but we can also go diagonally. 3 and 4. So those are 4 lines of symmetry. This one, I don't care where I draw a line, there won't be a line of symmetry. So this has none. So those are my lines. Now for rotational, what you need to do is be able to turn your foldable. So this smiley face, keep turning it and see if you can ever get this exact same image back to you again in any turn. And if you actually do it, take your foldable and turn it, there is no way you could turn it and get the exact same image. So none. And what I mean by that is if you keep looking straight and you turn your foldable, it will never look that exact same until you turn it around 360 degrees. On this one, if you turn it, you actually will find that you can turn it up to 6 times and make it look the exact same. And that's because you see all these little points? There are 6 points because this is a hexagon. And so what you do is you do 360 divided by 6, which tells me that you can turn it every 60 degrees and get the exact same picture again. So your rotations of symmetry are 60 degrees, 120 degrees, 180 degrees, 240 degrees, and 300 degrees are all the different ways that you can turn this and still get the exact same image back. So if I turn it 60 degrees, it'll be the same. 120 degrees, it'll be the same, and so on. On a circle, this is the same thing. You can turn this thing over and over again, and it will always get you the same thing. So this has infinitely many rotational degrees that you can write for it, because not only can you just turn it 1 degree, but you can turn it 0.1 degree, and you can turn it 0.01 degree, and it'll still look the exact same. So it has infinitely many degrees of rotational symmetry. This one, if you look, it looks the exact same because it's in all the sides and arrows and everything are the exact same. So whenever that happens, it has 4 points. So we're going to do 360 divided by 4, which is 90 degrees. So you can turn it every 90 degrees and get the exact same back. So that means that our degrees that we can rotate it is 90 degrees, 180 degrees, and 270 degrees. We never list 360 because remember it says right here it's got to be less than 360. With this, if you turn it and you keep turning it, you will not get the exact same back until you reach 360. So this one has none because remember they have to be less than 360. Okay, these guys, whenever we are reflecting across the x-axis, so we have A, B, oh, not prime, sorry, just A. B and C, and A is at negative 1, 2. B is at 1, 2, 3, 4, 5, 6, 0. And C is at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, at 5, 5. And then we're going to reflect it across the x-axis. So all that means is we're going to count how many away it is from the x-axis above, and we're going to go in the opposite direction, so below. So A is 1, 2 above the x, so we're going to go 1, 2 below the x, and that will be A prime. C is 1, 2, 3, 4, 5 above, so we're going to go 1, 2, 3, 4, 5 below, and that is C prime. And I'm going to take these squiggles off just because they're taking up room. B is actually on there, so it's not going to move. B prime will stay there. So then we have our new triangle. And A prime is now at negative 2, negative 1, negative 2. B prime is at 6, 0. It's in the same spot. C prime is at 5, negative 5. So all that happened from our original xy is that the x's stayed the same, and then we changed the sign of the y. So whenever you reflect across the y-axis, all that happens is that your y changes its sign. Whenever we reflect across the y-axis, we do the exact same thing, except we're going left to right instead of up and down. So my x point is 1, 2 right, so we're going to go 1, 2 left for x prime. Our z is 1, 2 right, so we're going to go 1, 2 left for our z prime. And our y is 1, 2, 3, 4, 5, 6 right, so we're going to go 1, 2, 3, 4, 5, 6 left. And that is our y prime. So x, y, and z, all of the originals. X is at 1, 2, 1, 2, 3, 4. Y is at 1, 2, 3, 4, 5, 6. 1, 2. And z is at 2, 1, 2, 3, 4, 5, negative 5. And whenever we reflected it across the y-axis, our x prime is now at negative 2, 4. Our y prime is now at negative 6, 2. And our z prime is now at negative 2, negative 5. So whenever we reflect across the y-axis, the only thing that changes is that we change the sign of our x, and our y stays the same. And lastly, we reflect across y equals x. So we have r, which is at negative 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. S is at negative 1, 2. And t is at 1, 2, 3, 4, 5, negative 6, negative 1. This one, whenever you reflect across the x and y axis, it's easier to graph it and then write your points. Whenever you're reflecting across y equals x, it's actually easier to do your points and then graph it, because all that you do is you switch your x and y values. So if your original was xy, then it will become yx. So negative 4, 6 becomes 6, negative 4. S becomes 2, negative 1, and t prime becomes negative 1, negative 6. And then plot it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That is r prime. 1, 2, and negative 1. That is s prime. And t is at negative 1, 1, 2, 3, 4, 5, And we are officially done with reflections and symmetry.